So, section 4.1 is representing relationships. And since we learned about linear equations last chapter, we're going to go back to those linear equations. The y equals mx plus b is the one that we're going to use most from here on out. But we still have that point slope form that we could use if we wanted to. But for this first chapter, for this first section, we're just gonna concentrate on that y equals mx plus b. So when we have this equation, it's called the slope-intercept equation for a reason, because you need the slope and the intercept in order to complete out the equation. The equation always has the x and y left in it. So this variable and this variable are always going to be there. You're going to replace the slope. You're going to replace the y-intercept. This time they're giving you charts with information. So say we want to do some conversions between quarts and liters. And they tell you that 1 quart is 0.95 of a liter. So that means 2 quarts is 1.9. 3 quarts is going to be 2.85. 4 is going to be 3.8, and so on. Okay, so if we look at this chart, we can see that each time our x's are going up by 1, our y's are going up by 0.95. That change right there is going to be our slope. And we can get our slope right from there because these are only going up by 1. So when we look at the difference between our x's, those are 1. The difference between our y's are plus 0.95. So when we put our y's over our x's, we get 0.95 over 1. So when we go to our equation, we have half of what we need. And we have to figure out what the next one is. If I look at this progression, but I go backwards, and I say starting at 5, it's 4.75, I would have to subtract 0.95 to get to the previous one. So 4, 3.8, subtract 0.95, 3 quarts is 2.85 liters, subtract 0.95, 2 quarts is 0.9, subtract 9.5, 1 quart is 0.95. If I go one more step and talk about 0 quarts, subtract 0.95, I get 0. This 0 right here tells me that I'm on the x-axis or on the y-axis. So this 0, when I go backwards, is the y-intercept. So our equation just simplifies down to y equals 0.95x. And because our y-intercept is 0, and there's a constant rate of change, this is also a direct variation problem. We talked a little bit about that in the last chapter. It's when the y-intercept is 0. In looking at most of the problems that they give you here in this chapter, in this first section, most of them are going to be direct variation problems. They're going to have a y-intercept of 0. I don't see any of them in here that don't have a y-intercept of 0. So what we're going to focus on for today is looking at the charts and coming up with what the slope would be, and then putting that slope in that equation. And we're going to verify that the y-intercept is 0, but we're not going to worry about it too much. That's what I was trying to say. Can't think this morning. So if you're given a chart like this, to go from 1 to 2, it's an increase of 225, 225, 225. So the other way to check and see if your y-intercept is 0 is your first y value the same as what your increase is? And if it is, then your y-intercept is going to be 0, because if you go back 1 unit, you would have to subtract off 225. So the 225 becomes our slope, and our equation is that. So with this equation, could you tell me, if I wanted to know what 10 was going to be in this chart, could you use the equation? My pen has been...
Don't you do 225 multiplied by 10?
Yep. So we're going to use that equation. We're going to put 225 times 10. 225 times 10 is 2,250. So we can create our representation. This is our representation of our relationship. And then we can use that representation to tell the next values or different values in the chart. Okay, they did give one problem. Okay, so let's look at this one. Just gonna say it out. Paul earns $25 for grooming. Grooming a dog plus $18.50 per day for boarding the same dog. So when you see those words per day, that's telling you that this is going to represent the slope. So if a dog stays for 1 day, he's going to be charged the grooming fee, $25 plus the $18.50 per day. So he's going to be charged $43.50 for 2 days. We're going to add $18.50 to that, and it's going to become $62. 3 days, we're going to add $18.50 to that, and it's going to be $80.50, and so on. So when we look at this change per day is $18.50. That is not the same as our first term, is it? So if they just come in and they groom the dog, they don't stay any days, how much is he going to charge? $25. So that 25 right here is going to represent the y-intercept. 1850 is our slope. $25 is our y-intercept. That is going to be our equation for our representation of our relationship between the number of days that he stays and the cost for grooming plus staying.
How did you get the 25?
Well, there's 2 ways I could get it. I could go backwards and say, take $18.50 away from $43.50, and that will give me the 25. Or I could just think about this and say, I'm bringing a dog in, he's going to get groomed, but he's not staying any days. So the number of days that he stays is 0, but he's going to get groomed. So he's going to be charged that initial fee of $25. Does that make sense?
Okay, I see. Thank you.
Okay. But most, if you're looking at it, I would say go ahead and subtract off $18.50 from the $43.50 to get that $25. So how much is he going to pay if the dog stays for 5 days? Well, we would take $18.50, times it by 5, and add 25 onto it. So he's going to be charged $487. That's not right. I put the wrong number in. $18.50 times 5 plus 25. How about $117.50? That was an awful expensive stay. What about for 7 days? We would do $18.50 times 7 plus 25. So a lot of the problems you're going to have, they're going to give you a story behind it, and they'll either give you a chart or they'll want you to make up a chart for it. So like this case, we weren't given a chart, we were just given a story, and we just had to logically think, what's happening here? How would I be charged for this service? I would pay the grooming and then so much per day. And whenever you see that word per, that's going to refer to the part that's changing each time or the slope of the line. Questions? Okay. Hearing no questions.